Hey guys, it's simple as that, aka the Friendly Freshman. So we got our first content video right now, which is on math. It's about transformations, like I said earlier. And today we're going to be focusing on a couple things. First thing we're going to focus on is line symmetry, which has to do with reflections. And we're going to come up with some rules for reflecting over the x and y axis and other equations like reflecting over y equals x, reflecting over y equals negative x. We're going to come up with rules for all of those so you don't have to draw a graph, you can just do the math using those rules to reflect. So let's start with the four different types of transformations. First of all, transformation is manipulating any point. It's transforming something. So there's four types. You can reflect something, you can rotate something, you can translate something, and you can dilate something. I'll go over all four of these as time goes on, but today we're just going to focus on reflection. So first of all, let's go over symmetry. There's a lot of different kinds of symmetry. So right now we'll just focus on line symmetry. And line symmetry basically means that if there's a line of reflection, so let's say we have a rectangle like this one, and we want to determine if it has line symmetry. Well, I'll give you the informal definition of line symmetry. If you fold over the point of reflection, the line of reflection, the figure is going to meet up with itself and there isn't going to be any stray edges. So what is a line of reflection, you say? Well, it's exactly what it says it is. It's a line that you reflect over. So in this case, this would be the line of reflection, and if you moved this piece over so that it would fold over, it would meet up with itself and there wouldn't be any loose parts, and that is line reflection. This is not the only line of reflection though. There are two lines of reflection on a rectangle. There's a vertical. This is a vertical, and this right here is the horizontal. And some people might ask, well, what about diagonal, like this? Well, no, this isn't a line of reflection. You could try it for yourself. If you take a piece of paper, which is a rectangle, and fold it diagonally, it will not meet up. The shape will be something like this. I'm going to try and draw it. So here it is. And then it would fold something like that. It would be something like that. And it wouldn't, because this part right here, part right here is a loose end, and so is this part. So nope, it wouldn't work. So that's line symmetry. Very simple. It's very basic. So now that we know line symmetry, let's use a couple points and reflect on the coordinate plane. So I'll pick this point right here. Actually, I don't like that color. It's a blue grass. Let's go dark green. So I'm choosing this point in the second quadrant, and I'll call this -1, 2, and I'm going to reflect it over the x-axis. So x is the line of reflection. So what we're going to do, it's really simple. This goes for any line of reflection. You count the distance to the line of reflection, and the direction that you count in is always going to be perpendicular to the line of reflection. Okay? So you count. So it's 1, 2. And there's 2 spots. There's 2 numbers. It's away from x, the x-axis. and then in the same direction you go that distance one more time. 1, 2. And then that is your reflection. Simple, right? So what is this point? Well, I'm sorry that I don't have like the lines in the graph and everything, but I probably will next time maybe. This point is, whoa, that is pretty sloppy, hold on. This point is -1, -2. Sounds simple enough. So I'm going to explain that again. If you see if x is our line of reflection, the direction that we're going in, which is like this, right? It's perpendicular to the line of reflection. That is very important. You need to know that. So let's think for a second. We started at -1, 2, and then we reflected it over the x-axis, and that became -1, -2. And this r right here, this simply just stands for reflection. And then in subscript we have what we're reflecting, which is the x-axis. Don't confuse r with rotation or point reflection or all the other, because they all use the letter r and it's really confusing. But the subscript will always tell you which transformation you're using. Anyways, ignore me if that confused you. So we started at -1, 2, right? And we ended up at -1, -2. So what rule can we make up to make, like, so we can come up with any reflection over the x-axis? Well, if we call -1 x and 2 is y, if we let x be -1 and y equals 2, well, and we reflect over the x-axis. Well, actually, this is how you were supposed to write it. Our x-axis, x, y, arrow. So what do we end up with? Well, x is the same, -1, -1, so we just put x, but the y value has been negated. Interesting, and this isn't a coincidence, so we just put -y because that is what we're doing. 2 is y, so -2 is -y. And I think we've just come up with the rule for the x-axis. X, comma, y, 2 maps to x, comma, -y. That works for any point. I'm going to prove it to you right now. I'm going to leave that rule up there. Yeah, so let's pick this point, 3, -2. Well, if we let 3 equal x and -2 equals y, it maps to x, -y. So 3 stays the same and 2 is negated, or made the opposite. 3, 2, so 1, 2, 3, 1, 2. As you can see, that looks about right. See? Ta-da! Alright, so now we're going to do the same thing, except we're going to do it over the y-axis. Let me get rid of all this stuff right here. We don't need that. So let's pick another point. How about this one? I'm feeling very negative right now. This is the 4th quadrant. This point is -1, -4, let's say. Reflecting over the y-axis. Well, our line of reflection is this right here, and so we are going to go in the direction that is perpendicular to the line of reflection, right? So 1, and now we're at the line of reflection, so there's 1 space. And then we go 1 more, and that is our reflection. And that is 1, -4. So let's do the same thing. R but this time it is y-axis, x comma y. So what does this map to? Well, we have -1, -4, and we changed it to 1, -4. So if we let 1 equal x and -4 equals y, well, x just stayed the same, it's just x. Actually, excuse me, x changed from -1 to 1. What am I saying? So it's made the opposite, or it's negated, so it's -x, and y stayed the same. Sorry if that confused you. I confused myself for a second. And so it's -xy, so you can just say that the rule is -xy. Now this is interesting because our x-axis of x comma y was x -y. We're doing a reflection of the x-axis, but it's the opposite value that was negated. Same thing here, y, but it was x that was negated. Interesting. And that's actually a helpful way to remember these rules. So I'm actually going to end this video here, but I'm going to talk about the other two line reflections really quick next video, and I'm going to have an actual graph that is nice looking. We're going to do a reflection of y equals x and y equals -x. So leaving off here, recap everything. Wrote a line reflection over the x-axis, starting with any point xy. It will map to x -y, and vice versa. Reflection over the y-axis of any point x comma y will map to -xy. That's basically what we learned today. See you next video.